And I hope you guys had a chance in the morning talks to think about all the wonderful features you want to add to the POSIX extensions. When you talk about these real workloads, these unusual loads on storage, it's fun to think about that in the context of what protocol extensions we need, given that Jeremy and I just had our talk yesterday about the SMB3.1.1 protocol extensions. So hold the thought about any ideas that you may want to see for the extensions. But we're going to go today and talk more about the SMB3.1.1 support in the client and about how that's improved radically over the years. I think you get a chance later today to hear the Windows Server improvements, the Windows Client improvements. I know we'll also get to hear some exciting RDMA improvements later from Matthew and others. Once again, these are not necessarily the opinions of Microsoft, but it is a very exciting time. I moved to Microsoft about 1.5 years ago, and it's been interesting to be in this cloud world where the difference in speed of these Linux VMs can be orders of magnitude, and it's been a very exciting time. Okay, so I'll give you a little bit of an overview of the general Linux file system status, what's driving these things, and then dive deeply into some of these features. And then talk a little bit about the exciting work on CIFS utils and some of the stuff Pavel and Ronnie and some of their co-workers at Red Hat and SUSE have done. Okay, so a year ago, Linus likes these fun name symbols. So how many of you guys like this moray eel here? I thought that was kind of cool. So we went from a merciless moray last year when I was presenting to this bobtail squid, which I don't like quite as much, but that's the current Linux's name. That's a good question. I saw a moray eel attacking, but I think the bobtail squid might have more trouble surviving. Yeah, so my theory is that because of Andrew Tridgell and because of Samba, the penguin is a ferocious animal to many Linux people and even got adopted as the Linux symbol, and it's all because of Samba and the SMB protocol that the penguin exists. But Chris can tell you all about that history. And for those of you who... Yeah, and so for people who are curious, SMB, this protocol we're talking about, and Linux, every time you see the penguin, it should be a reminder. Okay, so what's driving the file system activity today? It's not just Amazon Cloud, Azure Cloud. It's not just about new workloads. Things in the kernel. At the File System Summit in Puerto Rico, we talked about the new Mount API. Improving support for containers came up a lot at the File System Summit in Puerto Rico this year. I think some of you guys saw the email threads about the unification of credential management and the kernel keyring. And of course, maybe a quarter of the talks around here, maybe more, are about faster storage, persistent memory, NVMe, accessing it over RDMA. This better support for faster storage causes changes in the commodity protocols that use it. Obviously, you don't want to be accessing files by writing to a toolkit, right? You'll be accessing files over normal protocols or over a normal file system like XFS or ext4 or a network file system. How do we support this, though? How do we expose those features that are being done by these NVMe communities, by these other communities that are working sort of semi-independently and maybe not communicating as well with the higher level services like Samba? IOU ring for async IO. A few months ago, copy offload was fixed to allow copying between two cloud shares. It used to be that you could only do copy offload in Linux between files on the same mount, the same superblock. Right now you can use copy and clone range to copy between one SMB share and another. So this is very helpful for those who might be trying to move shares on the server with zero cost. And of course, the shift to cloud introduces issues with longer latency. I can't tell you how many bug fixes were found by Pavel and others relating to reconnect and crediting due to this. And of course, lots of performance issues when you have objects and files coexisting in the cloud. But I think we should step back a little bit and think, Linux is now at 5.3. Why did they change it from 4.20 to 5? You have a theory, Chris, on why they changed it to 5? It must be because of Samba or SMB. That was my theory.
It must be.
Yeah. So anyway, so Lena said, find your favorite feature and go wild. So I found my favorite feature. This is the reborn, new, improved And to some extent, I feel comfortable with 5.0 and later. As a developer, I'm aware of all the ugly, dirty warts, but I feel much more comfortable with 5.0 and later. Partly because of improved testing, but partly because of all of these incredible new features. Now, as you probably know, in the Linux world, we deal with some incredibly good developers. Here we are at Puerto Rico at the File System Summit, and I think you'd recognize some of the people here today who were in that picture there. And it's also fun because last week we had a bunch of people at Microsoft at the Samba I/O Lab, and it was a fun group testing and working together. We follow up that work this week with a lot of the testing downstairs. I encourage you guys to keep working on that stuff. But I like this, that we have this pace of test events every 2, 3, 4 months, regular test events, and the conferences in Germany, and the ability to work together, because the pace of change has gone way up. And you can see that if you look at the most active file systems. 5,300 change sets in the file system is a pretty big number. The activity's down a little bit, but it's still 6% of the overall kernel changes. The kernel's 18 million lines of code, right? This is big. Now the problem is, in Linux there are more than 60 file systems. Now think about that. People have weird reasons. They might use the 9p file system, or they might use some AFS or whatever. But what are the most active? Almost all of the change, or way over 2/3 of the changes, are dominated by these 6 file systems. And CIFS is by far the most active network file system. And the 3rd most active file system, BTRFS and XFS, are ahead of it. And it's 53K lines of code, but it gets a lot of attention now. And I tell you what, I get emails from code cleanup people running these weird automated static checkers literally every day. The cool stuff that happens as you optimize Linux code. So you want some change detail. BTRFS the most active, over 1,000 change sets. The VFS layer itself, 775, but that's down a little bit. XFS activity is up a little bit at 521. CIFS activity is way up. It's not quite to the level of XFS. It just missed XFS. And then F2FS, and then as you go down, NFS had 328. But notice that it's really those 6 file systems that kind of dominate the activity. But then compare that with Samba. A couple of you guys here enjoy talking about Samba and work on Samba. It's 100 times larger than the NFS server. It's 3.5 million lines of code. And it had 5,300 change sets. In the file server component of Samba, measuring it strictly, there were over 1,000. NFS total had 137, right? So, 137 for NFS server. In the file server component alone of Samba, the strictest measure, over 1,000. So, SMB is pretty active. And why? Well, as Ronnie showed you in his talk yesterday, there's a lot of weird embedded devices. There's all kinds of crazy servers you've never heard of and clients you've never heard of that use SMB. And why? Because we have this kind of commodity protocol that can access anything. Macs, Windows, Azure, Linux, Samba, every OS imaginable. So what's our goal? We want to implement all the reasonable POSIX features, either with new protocol features if necessary, or with using this enormous set of tools we have in the protocol to allow Linux as it evolves to be able to deal with these features. But let's talk about some of the great progress. So let's take a specific example you might be talking about. Anybody ever write a presentation for SNIA? You might want to take a snapshot, and like save off an older version of your presentation. You can mount with a snapshot parm. And we added the code to SMBinfo tool to make it easier. So here is an example from not too long ago, before one of my earlier presentations. I mount with a snapshot parm. Now look at mount 1 versus mount 2. One of them has a new file not in the snapshot. Notice these new directories, new files that are not in the snapshot older version of it. So we've got 2 mounts to the same place, one with the snapshot, one without. You can see the difference. If you want to see it inside the GUI, here's mount to Azure, okay? So Azure, like many servers, supports snapshots. So we're mounted to the cloud. Maybe you're saving off your presentation. And you can see in the file manager in Linux, right? You see the difference between the 2 snapshots in the current version. we're looking at it inside the Linux file manager mounted to Azure. And we have 3 different versions of the data, different snapshots. The snapshots are read-only. It's super easy to use, especially with the smbinfo tool, and something everybody would use, potentially every day, right? I mean, backing up snapshots, presentations, whatever. Okay, rsize and wsize, a lot of focus on performance. People with these weird workloads come to us. We had a previous default of 1 megabyte for the I/O size, I think similar to NFS. When we boosted it to 4 megabyte, it gave a 1 to 13% improvement, depending on the server type. Not a lot, but enough to make it worth moving up. So in the 420 kernel, late last year, we moved it up to 4 meg. And also, we found some tools that were kind of stupid. The CP tool, for example, queries the inode's block size to decide its I/O. And you really don't want to be sending 16K I/O across the network, especially if you're running unbuffered. So like with NFS, we moved it up to 1 meg. It had one unfortunate side effect. Some test cases base the size of the test run on a multiple of the block size. So it runs a test case on a file system that says its block size is 16K, and it's a lot faster test because they're doing a lot. But other than some test cases, we found an xfstests who did this rather odd thing of basing the test case size based on this. It helped performance significantly for tools that look at the block size as a hint to what size I/O to do. And obviously in the network, we normally want larger I/O. DFS support. One of the fun things about SMB is its support for global namespace. So Paolo at SUSE, with some help from Aurelien, did some really neat work for DFS support. But they not accidentally, on purpose, fixed some things that also were loosely related that didn't involve DFS that I'm really glad about. So I love it that we can handle failover. That's great. So you can set up your DFS server and we'll automatically reconnect if the network goes down. We'll automatically reconnect to a replica. What I really like is they also fixed it if the server's IP address changed. The same kind of code, they were able to reacquire the new IP address for the host. So if a host was running DHCP or if a host was taken down and moved, they were also able to fix that. So this was really cool. But I love this DFS feature that we can reliably export multiple servers exporting the same data, and if one of them goes down, auto reconnect. We spent a lot of time talking about the security model for SMB and how best to map the complicated Linux mode world into the NFSacl, cifsacl, richacl world. And one of the things we have is we got 2 separate problems. One is how do we store the owner? Because we don't always have RFC 2307 set up. We don't always run SSSD or WinBind. Secondarily, how do we set the ACL? So we have the problem of the ACL, and we have the problem, the mode bits, and we have the problem of the owner. So for argument's sake, say you're creating a file or making a directory. The things we have that control this today are we going to rely on the default owner, right? We're going to go ask WinBind who the owner is, or just let the server default to whoever it thinks the owner should be for that file. Or are we going to get the ID from SID? ID from SID here. So we're going to mount with ID from SID, where we are going to use a well-known security identifier based on the UID. So a prefix followed by, for UID 1, it has 1 at the end of the SID. So ID from SID, or we rely on the server or WinBind to give us the owner. Mode from SID means that, like the Windows NFS server, we store an extra ACE that's not enforced that has the exact mode we think the client expects. This is kind of like the NFS model. You kind of trust NFS. Maybe it's not secure on the wire, but you trust NFS, and the mode bits can get enforced on the client because we preserve exactly, the 7777, we preserve all of those exactly in a special SID, an ACE that will never get enforced, it'll never match anybody, but we can retrieve it on the client and get the perfect mode bits. And then we do our best effort for the other 3, user owner, group owner, and everyone. Mode from SID. cifsacl doesn't send that special ACE, it just relies on estimating as best we can the ACL based on the server. We try to set the user owner, group owner, and everyone as close as possible to what the mode bits would expect. If everyone has read-write permission, then the mode bits will show everyone has read-write permission. The third model is we don't have the cifsacl mount parm or the mode SID up mount parm. We just rely on whatever the server created for the ACL. In the case where we don't have We're not changing the ACL. We're not setting the owner. We don't even have to send a security descriptor on open. This is the code that we were working on in the Plugfest yesterday, cleaning this up. Some of these are, the cifsacl is implemented, but some of these need to be set on create and make dir to avoid races on open. The beauty of SMB is you can set all these ACL information in the open security context. That was what we're working on yesterday. Now, very exciting, Aurelian, with a little bit of help from Paolo, but Aurelian has been working on multi-channel. This is expected to be a big performance win. Windows Server supports multi-channel, and Samba, I think during the presentation Ralph gave yesterday, he had some good update on some of the multi-channel improvements in Samba. This is a huge win for certain configurations, especially if you have RSS enabled in the adapter. So here is a trace from, I believe, 2 days ago, maybe 3 days ago. It was fairly recent. So you can see the channels by color. So we've got 2 sockets basically open to the server, and we're sending our data over multiple sockets. And obviously, you can see the negotiate of the second channel here, and you can see the use of it down here, right? So it's kind of a neat thing because multi-channel, unlike other network protocols, is transparent to the user. When you mount with multi-channel, it figures out what network interfaces you have and connects to them. And one of the pieces Aurelian was working on right now was, do you use round robin to decide which channel, or do you pick channel based on other criteria? But the beauty of all this is it's transparent to the user. The user doesn't have to do some odd binding of sockets. He doesn't have to do any strange aggregation. It just works. It also is going to make RDMA easier because today when you mount with RDMA, you specify RDMA on the mount line, where this will allow you to negotiate RDMA only when the user has put the RDMA card in the machine. Compounding. Ronnie has spent a lot of his life on compounding, and I think you can't overestimate its value, especially in the cloud, because it cuts the round trip so much. If you look, for example, at unzip, or you look at common operations, the chattiness of Linux is crazy. Linux, every single entry in a path is queried, and queried over and over again. We cache it for a second, NFS caches it for like 10. Linux is a very chatty file system protocol. But look at like delete going from 5 to 2 round trips, make dir 6 to 3, remove directory 6 down to 2, symlinks using the Apple style MF symlinks 11 to 9, stat 6 round trips down to 2, and on, right? We have a lot of work to do. We can keep improving this number, but compounding and some of the work that Ronnie has done is probably the single most important performance feature for all those metadata heavy workloads. And it's beautiful in SMB because you can do the weirdest compounding possible, like Macs do. Macs do some of the really interesting compounding. But this effort started really around 4.19 kernel, so just after SDC last year. And the progress was huge. And the reduction in network traffic is a big deal. But we have so far to go in some things, right? Looking at workloads and trying to figure out why is it doing this? Big deal. Directory release support also helped. It'd be nice when Samba supports that, but Windows and other servers support directory releases. So another thing Ronnie did was sparse file support. So here is an example where he's querying the layouts of a sparse file. And you can see here's the layouts of the sparse file. Certain things like the CP command take advantage of this and will only copy the allocated ranges. So commands like CP and some of the Linux commands that are sparse file aware, it's much more common on Linux than on Windows. For apps to use this. Here's an example of network traffic using Ronnie's improvements. You can see the file range queried here, the query allocated ranges, and you can see the range down here, right? So we're querying from the server the allocated ranges. This is supported with Samba under BTRFS, for example, or to Windows. And here's some test code that he wrote to show an example of using sparse files. So setting sparse, zeroing the data, querying the allocated ranges, and also being able to seek to the whole or seek to the data in a file. So this is a big help for workloads that are optimized to take care of sparse files, which is much more common on Linux than you might think. And this was added in the last year. Now, debugging. All code is perfect, of course, except in the server. So client codes never have bugs, but sometimes it's helpful, right? So sometimes, let's for argument's sake, say you have a cloud developer or you have a Samba developer who wants to know why their server is doing something, and you can give them the wonderful traces, or sometimes you can even find a bug on the client, or both, which is the most common scenario probably. Last year we had about 20 dynamic trace points. The XFS developers had encouraged us to use the dynamic tracing facility in Linux, and so a little over a year ago we added the first 20. Now we're up to 77. We got a ways to go before we catch XFS, which is about at 550 trace points. Yeah, go ahead.
How useful are they?
I use them every week. Yeah, I use them every week. So I can give you just maybe anecdotally. Okay, so the zero range example, right? Debugging Ronnie's code, zero range. Slow response was one that comes up a lot. So you're running to Azure, you're trying to figure out, latencies look pretty good, the average latencies look pretty good, the median number looks pretty good in the server logs, but something's wrong, it's slow. And then you can go back to the developer and say, well, okay, I logged these slow responses. And they're like, well, 1 second's too small. Okay, well, I'll set it to 60 seconds and we'll see if any hit that threshold. But now we have the information they can now look up in their server logs or in their Samba logs or in the Windows logs and figure out on the server what this matches and why. Sometimes it's an fsync kind of thing, right, where the fsync itself is really slow because of some odd event. The one I use most often is, well, let's back up to around last December. We were constantly using the partial send reconnect, reconnect with invalid, whatever, the 4 or 5 that relate to why we reconnect, because we had some issues with crediting and we were trying to trace reconnection. Maybe the most common ones that you would use, or a typical person would use, would be the one where we map the errors. So we have ones that are on enter and exit with error. So that's the user's view of it coming out of the file system, enter and exit with error. But you might be wanting to look where we do the mapping of the error from the SMB error to the POSIX error, because POSIX has so few errors, and the SMB protocol has this huge set of errors. We had this come up with delete just recently, where a customer did something which sounded obvious, but turned out to be a bug in our client. Let's say, for argument's sake, you were running some app and your share ran out of space. What would you do? You might delete the share and recreate it on a bigger thing, or move it from drive C to drive E, right? We didn't, the server didn't go down, the server's still there, so we kept the session forever and was returning share deleted, share deleted, share deleted. Well, share deleted didn't map to anything useful. So, turning on dynamic tracing, you can see, oh, it's share deleted, okay. And then we added the code when we got share deleted, we marked the tree connection invalid, and now we reconnect to the new share. So if the server deleted a share and recreated it on a different drive or bigger, or in the cloud, provisioned a bigger share with the same name, we'd automatically reconnect to that now. But to debug it, how would you find it? Because you weren't returning share deleted. So dynamic trace points have been unbelievable. But what blew me away, and I recommend you guys go over to LWN or go to Brendan's website, Brendan Gregg's website, they asked the keynote for the File System and Memory Management Summit in Linux this year, the keynote to be given by a guy who works on the eBPF, the Berkeley Packet Filter, which is now the infrastructure around dynamic tracing. And he's written books on this, and there was a group of 7 or 8 developers there giving presentations about it and having some separate breakout sessions, trying to encourage file system and memory management developers to use this new infrastructure. As an example, Aurelian and I last week were looking at a slow something problem, and the things that are possible with dynamic tracing are staggeringly amazing in Linux now. The problem is just not knowing it, right? So guys like Brendan Gregg who have websites and blog entries about this are super useful. But for guys who do any server development or client development work on Linux, this would be something you need to do like every week. Okay, so super exciting news. At Samba XP this year, Samba XP a few months ago, Andreas gave some presentations on GCM support for Samba moving to GNU TLS. And I tried with this tree, got it working, added the GCM support, it's in the 5.3 kernel, and man, is it fast. So, I did some experiments a couple days ago. So this was mounting with, okay, this is this laptop, okay? No tricks here, right? This is this laptop. I'm mounting to myself, so it's fast network connection, obviously, you're mounting to yourself, but kind of gives you a best case example, right? 3 times faster for large writes. 556, 574 versus 181, 172. So this system, mounting with GCM versus CCM, the default now is 3 times faster. Reads 2.5 times faster. 822, 823 versus 333. That's this system, 2 days ago. So obviously, you may even get better data if you had faster storage, but it's taking many milliseconds to encrypt with CCM. GCM with the hardware offload is amazing. So obviously, for smaller random I/O, it's going to be less useful, but for large I/O, I'm not going to complain about tripling my performance. And I did some experiments, to Windows and Azure, with faster VMs, and I was getting way over a gigabyte per second easily in Azure to Windows, Linux to Windows, and it's kind of fun to see encrypted shares that fast. Okay, so let's take a look at this. Would you want to boot a diskless system, have a kiosk? If your I/O is that fast, that it's encrypted and it's safe, why wouldn't you have kiosks in diskless systems? We used to do this in OS2 years ago. We used to do it in Windows, have diskless boot. Sometimes the root file system in CIFS is interesting. So this is a picture from last night. Paolo from SUSE sent me this picture. Here's a system that booted. Let's see, hello world from Samba rootfs, SMB rootfs. And it shows it's mounting using OpenSUSE Leap. And this is the current kernel. There's one change that's waiting on Dave Miller for the net tree. It's a very small change to the net tree, but the rest of it's checked in. So I think we're fine except for that one small change. And that should be in the next kernel, I would expect, unless there's some odd problem I'm not aware of. So we have a very small dependency on this, but the CIFS part of it's in, and there's a very small net change. But booted last night, showing, and he describes in some of his write-up on how to set it up. You can see that you set CIFS root equals that. The current limitations, no IPv6 support, and it defaults to SMB1 because we don't have the ability to create FIFOs and special files in the current code. That's something we're working on right now in SMB3. One of the things that came up in the POSIX Extensions talk last night was the ability to create the FIFOs and care and block devices over SMB3. It's not a big deal, but once that's in, he'll be able to boot over SMB3, not just SMB1. The NetName context may be useful for people in the cloud or people trying to do debugging or monitoring. The NetName context shows the server name when you connect to an IP address, and may help the load balancers because on the first frame you send on the wire, you know what host you're trying to contact. And if you're all coming through the same IP address, you can reroute them differently. And it may be useful for debugging and figuring out things like, you're trying to access Coke.com and you're trying to access Pepsi.com, but they map to the same IP address. And it's a helpful thing, this NetName context. And Windows added it a few months ago, and so did we. We can say a lot more information about open files. One of the problems you have in Linux is people don't realize they leak files in an app, and that can be a problem in the cloud where you've got thousands and thousands of VMs potentially leaking handles. So one of the things you can do is you can run LSOF, but this gives you the information you need to find it in the server logs. So being able to see the persistent file ID and the tree ID, you can find it in your server logs. So adding that sudo file, open files, to allow for this debugging turned out to be very helpful for some workloads where apps were badly behaved. RDMA, performance keeps improving with RDMA. It's no longer considered experimental. Long Lee got a chance to work with Metza and others on this last week. There were lots of fixes and improvements earlier in the year, and I think, performance I saw was pretty good with RDMA. And it's going to be even easier to use with Aurelian's multi-channel changes because you won't have to specify RDMA on the command line. You can view the statistics have much improved, and we use these all the time. Customer comes in with a problem, says something slow, now you can look at it and say, is it a read-centric, is it a write-centric, is it query info, is it metadata related? And there's some fun things like we can figure out how many files are open on the share at that time. A lot of times the user doesn't realize what their app is doing. The slow response threshold we discussed was very helpful for debugging. it defaults to 1 second, and then you can turn on this trace value and it'll log commands that take more than a second, but you might want to set it to a higher number. But this allows you to do debugging when you have a temporary problem. I remember we had an issue with a cluster file system years ago where every once in a while the close would take like 3 minutes because it was doing some fsync and load balancing or something weird under the covers that would cause incredible delay. This helps identify that easier so the server developers can find the problem. Okay, let's summarize some fixes by release. Last year, we talked about these, the SMB POSIX extensions, that minimal set that went in, the SMB3 alias, because you don't want to be mounting with CIFS, so you can mount with SMB3. You can ins mod SMB3, which disables, disabling less secure SMB3 by default in those cases. We added the dynamic tracing we talked about, those first 20 points, and caching the root file handle and reducing redundant open. So a year ago, we got to thank Ronnie for this great work. We need to extend that, though, to other files and to other directories. Now, 4.19 was super fun. The snapshot support, SMB3.1.1 is now always built in it. We could disable SMB1 in kconfig, and SMB3.1.1 is always built in. And there are some really important bug fixes relating to lease breaks and some security things. In 4.20, RDMA performance went way up. Compounding was that improvement we talked about earlier. But I also want to talk about something called the query info pass-through. One of the things that Ronnie had this idea, and I think it was very valid, that sometimes you just want to write a quick and dirty user space tool that uses the mount to send ioctls to query information or to set information or to do some fsctl, maybe even for debugging, maybe a private ioctl for debugging. And so we started to add these pass-through modes so you could open a file on the mount and then pass through these requests across the wire, and that allows you to write user space code that's quick and dirty throwaway Python code. And I'll give you some examples in a minute. So in 5.0, we now request SMB3.1.1 by default. And we added the DFS failover support we talked about. You can cache these DFS referrals as cached. And if the server's, very important to me, is if the server's IP address changed, right? You're in Azure or something and the server migrated from one IP address to another, that was taken care of. And then we added this compounding for getAttr setxattr, and there are some really important file stability fixes for reconnect. So the pass-through improved in 5.1 to allow to query any available over, basically any query info call you could set over the wire, you could also set from user space through this pass-through. This handle timeout allowed you to control persistent and resilient handle behavior. We added the fallocate 0 range. We improved the performance quite a bit. Added support for guest mounts of 3.1.1. Now in 5.2, we added the seek seek data stuff and that 0 range support we talked about, and then allowed you to do the writes for the set info pass-through. In 5.3, more recently, we cut the performance of open by cutting the number of request round trips from 3 to 2. We now return in an open context what used to require another round trip. We improved the performance of read and write, which we showed you with GCM. It can triple it in some cases. Copy file range across shares. SMB direct is no longer experimental. And you can now query the symlinks to the Apple guys, and we were talking this morning about querying symlinks. We can now recognize symlinks stored as reparse points. In 5.4, the current stuff that's in the merge window, you can boot from CIFS. Got the one change needed for the network stuff, but all the CIFS part of it's in. This new modefromsid parameter allowing you to set the mode bits in a special, the NFS ACE that Windows uses. We added a performance feature to allow you to optionally offload decryption of larger reads to a separate thread or a set of pool of threads to improve performance in cases where encryption is slow. And we have a new mount options for cases where you know you're the only guy using it, so you can force read caching or force read write caching in cases where you know you're the only guy using it, and you don't feel like setting, in some cases you're not getting leases, or we're not asking for leases, and we could be. This just forces caching on for a read-only or read-write case if we know we're the only ones do it. Also, we added this parameter sign loosely because signing is pretty expensive in SMB. It's actually slower than encryption with GCM, and sign loosely lets us turn off the sign checks on the way back. Also, we added this ability to dump the keys to make it easier to run to view a Wireshark trace that's decrypted, and the multi-channel support we added. Tentatively for 5, what we're talking about is the supporting swap over SMB3, some performance optimizations, improving the parallelization of encrypted writes, which today kind of serialize on a mutex, and improve the caching of the root directory by, and also improving caching when you have cases that you see commonly in NFS, where you open a file, write some temp stuff to it, close it, then reopen it. We throw away the cache where NFS caches it across close and Windows caches it across close. So improving the caching of files that are briefly closed and reopened. The bug count has gone well down in bugzilla.kernel.org. It still could use some cleanup. Most of these are possibly already fixed. We need some extra attention to clean these up. But one of the exciting things I hadn't talked about was CIFS utils. So CIFS utils, user space tools, today has mount helpers and things relating to setting ACLs and this sort of thing. We added this thing called smbinfo, and Ronnie and Aurelian and others have had some fun playing with this. But here's a list of some of the things you can query. A lot of this is metadata that's not available over POSIX. It's things that you wouldn't think about. Listing snapshots, it's getting the object ID for a file, or getting all info, printing it to the screen in a way, even for the stuff that's not Windows, not POSIX metadata. So as another example here, we're getting file all info on a file. Notice that you can see not just the timestamps, but also the DOS attributes and mode bits, whatever. So the file alignment, right? We can dump all the info that comes back on query info for a file, even if it's not POSIX. We even have a GUI now to let you set ACLs. In smbinfo, as you can see here, we have the ability to do many things, including ACL changes and views. And here we have a GUI, a Python GUI that lets you do it. That was an experiment I think Ronnie did a few months ago. And another example I just got yesterday of how you can use these tools, and something that looks likely we'll add, was for quotas. So the ability to quickly write Python code in user space that accesses non-POSIX features for tools is kind of cool. So here's the example from Kenneth D'Souza, SMB2 quota. So here, yesterday I asked him, can you show me some examples? And so he sent me a screenshot of some examples. And he's dumping quota information to the server from a user space tool. What I love about this is quick and dirty Python tools that people find useful for debugging, for systems management, are so easy to write now with this pass-through IOCTL. So CIFS utils has really entered a new era here. But the most exciting thing, and why I think we've kind of entered a new era with SMB3, has been the automated testing, the buildbot. So Paolo, Ronnie, and Aurelian have done a lot of work on that. And you can go to the URL, it's all public, you can go view these. You can see which XFS tests we run. We sometimes have problems because the XFS tests change and regress. So the list changes sometimes, and sometimes we fix things and we add. But we're now up to a pretty large number of test groups, more than NFS runs, which is kind of fun. And there's still a lot of work to do to get us to the about 30% of the tests aren't really relevant for a network file system because they require a block device. So, but we have about another 100 test cases that will probably be enabled over the next year as we go through some of these features and some of the POSIX extensions and some of these accommodations we've been discussing over the last few days. But what I love about this is it means that we're catching regressions earlier. We've caught, how many regressions, Ronnie, do you think we've caught?
I think in the last 6 months, in what we pushed to Linux, there has only been one single patch that was the regression, and that was the one single patch that did not go to your tree.
Yep. Oh, that's right. Absolutely. Actually, that's a really good point. So that's a fun.
We used to have regressions every single pull request, at least.
Yeah. Yep. So that's actually a really good point, is that the signal handling guys changed the way signal handling works, and it did not go through Archie. It was a global change, and it broke multiple modules. They did not catch it. We were the only ones who reported it because when the merge window, or, after that pull request, our stuff started to break when we ended removing the module at the end of the test, broke because of this regression in a global kernel change. The other modules didn't have regression tests and catch this. They only caught it weeks later. We caught it, and we caught it within a few days. So that was great. It went into Linus's tree because they didn't go through my tree. It regressed. We caught it quickly, and we avoided a disaster. And I think what's nice about this is that it gives people confidence, but it also allows something really cool. If you as a customer find a bug, or you as a server see us doing something wrong, well, we add a test. We have CIFS-specific tests. You've added tests for CIFS-specific stuff. So the beauty of xfstests is it gets thrown in a CIFS bucket or in one of the general buckets. We run it. From there on, it'll never regress because we'll always be running on it every pull request they send to Linus. So here's an example of what the screen looks like. Pulls the Git trees, pulls the test tools, runs a long set of tests with different mount options, different server targets. We have about 5 test targets right now, including Jeremy Allison's POSIX Extensions tree. But the ones we use in our regression bucket include some testing against Azure, some testing against Windows, some testing against various configurations of Samba, and then we have these DFS tests as well. And then we have individual buckets like Windows and Azure that just focus on tests only to that target with different mount options. Yep, go ahead.
I like the fact that you can actually run xfstests without causing further panics.
Yep. Yeah, I think that's really fun. And and this is actually in Azure. The infrastructure for this is in Azure, right? So we spin up Azure VMs to run the VMs and VMs. And but we've also, if people have services available in Azure or an IP address we could connect to, maybe with support for Quick in the future, we can even have ones that aren't located near it, right? We'd love to have NetApp servers and Mac servers and other things in this infrastructure because we want to run with as broad a reasonable set of targets, at least 1 or 2 tests, to make sure we don't do anything crazy because you would not believe the weird little differences in server behavior. It's quite remarkable. Anyway, the buildbot is making 5.3 the best release ever, prevents regressions, and it continues to improve quality. One of my goals for the next 2 or 3 days of the test event is to keep fixing more xfstests because there's the strangest stuff, NTFS rounding up, sparse file stuff, and weird assumptions people make about what the server file system is going to do built into these tests. And getting these behaviors to work in a way that Linux is happy with is super helpful for getting this working. And as I say, we run more than other network file systems. We just need to keep getting that number higher and higher and higher. So I don't know, I'm very excited about this, and I think it's going to be the best year ever for this stuff. 460 plus changes last year, and we're on track for that again this year. It's a great time to be working on this SMB3 stuff. Probably the best way to get Linux to access the broadest set of storage you can imagine. So great stuff. I want to thank Ronnie, Aurelien, Paolo, all the guys, Pavel, and all these guys have been contributing. I think we may have time for a question or two. I don't know. How much time's left? Anybody know? Much? Okay, so time for questions. So Ronnie, do you have a favorite feature?
That we don't kernel panic so easily anymore.
Yeah, that's good. Aurelien, you have a favorite one?
The one I'm working on.
Yep. So the kernel doesn't panic and multi-channel for Aurelien. That makes sense. Okay, so you guys have a favorite feature you want us to do yesterday? You guys have stuff? I think what I've been hearing a lot about is performance-related stuff because a lot of the uploads into the cloud. So let's keep working on that performance stuff. And I'm really excited also about the Samba progress and about the progress in some of these tools that Ronnie's been working on. That's been fun stuff. Okay, so I look forward to see you guys at the next event. Hopefully, Jeremy Allison will have all the POSIX extensions fixed by then. So we have and I do recommend you guys take a look at some of those slides because any feedback you have on those extensions would be helpful. And thank you guys.